Okay, so let's start looking more closely at atoms. What are atoms made of, and what information do we get from different parts of an atoms, and so on and so forth. So we, in this course of discussion, we'll talk about the word particles. You may remember me having used that word and not be very specific. It's a very general terminology. So I'm going to now make it more specific, talk about what are the different kinds of particles, and depending on the context, which terminology to use. Um, we will also talk about chemical formulas and learn the information we get from there. We'll talk about subatomic particles, the different kinds there are, and all the information we get from those particles. We will also have a brief discussion on isotopes. Okay, so let's go to particles. I've used the word particles before because I did not want to be very specific in my definition at that point of time, but particles can either be atoms or molecules or ions. A particle is basically the smallest independent unit that can exist on that exists in a substance, and depending on the kind of substance that we are talking about, we need to start using one of these specific terminologies. So the word particles is very general, which could mean any of these three different kinds. So let's define these three different kinds and now start using them. Atoms is the smallest stable particle that exhibits the properties of the elements. For example, one atom of helium will demonstrate or will exhibit the properties that we associate with the element helium. One atom of iron will have the properties that we link to the element iron. Atoms cannot be broken down into simpler stable particles, and please remember the key word is stable. Yes, atoms can be broken down into simpler particles, smaller particles, but those particles are not stable to exist on their own. Atoms of one element are very similar. Please note I do not say same to another atom of the same element. In other words, basically one atom of carbon will be very similar to another atom of carbon because they both belong to the same element, carbon. But atoms of different elements will be very different from each other. One atom of carbon is very different from one atom of helium, for example. They have very different properties because they belong to different elements. Atoms is the term to use. This is used when we are talking about when referring to an element, but a very specific kind of an element, an atomic element, and we'll talk about that in a few seconds. But that is when we use the term atoms instead of the general term particles. Molecules, on the other hand, are again individual units, individual particles that are created by chemical combination of two or more that are created by chemical combination of two or more atoms. Now, I would like for you to pay very close attention to this. The definition of a molecule says that it is created by the chemical combination of two or more atoms. Can you recollect the definition of a compound? In a previous session, we defined a compound as something that's created by a chemical combination of two or more elements. Please understand. Now, when I write O, this is an atom of oxygen. But when I write O2, that is a molecule of oxygen. But is O2 a compound as well? Because it has more than one atom. Is O2 a compound? The answer is no. O2 is not a compound because the definition of a compound very specifically says two or more elements. This is the same element. Both of the atoms in this molecule are for the same element, oxygen. So this is not a compound. But then if I say H2O. What is this? First of all, it is a molecule because it's created when chemically two or more atoms are combining with each other. But is it a compound? Yes, it is a compound because hydrogen element and oxygen element are combining together to make this unit. So please remember the definitions. They are very specific in that vocabulary. A molecule is created by a chemical combination of two or more atoms. Those atoms can be of the same element or different element. But not all molecules belong to a compound. That depends on whether that molecule was created with the combination of same or different elements. Okay, now molecules can be classified either based on the number of atoms that are present in each unit or based on the type of atoms that are present in each unit. In other words, molecules can either be diatomic, triatomic, or polyatomic depending on the number of atoms in each molecule. If the number of atoms in each molecule is 2, then those molecules are diatomic. If the number of atoms in each molecule is 3, then those molecules are triatomic. And if the molecule has more than more than 3 atoms, then those molecules are termed to be polyatomic. But molecules can also be classified as being homoatomic or heteroatomic molecules based on whether the molecule has atoms of the same element or atoms of different elements combining with each other. If a molecule has atoms of the same element combining with each other, then those molecules are homoatomic molecules. And if the atoms of different elements are combining with each other, then those molecules are heteroatomic molecules. Now, based on the discussion that we've just had, one of these kinds of molecules, homoatomic or heteroatomic, is a compound. Guess which one? Absolutely. Only the heteroatomic molecules are compounds. The homoatomic molecules are not compounds. If they're not compounds, what are they? Absolutely. Those are elements. Okay, so besides atoms and molecules, particles can also mean ions. What are ions? Ions are particles that have a charge. Any charge, whether it's positive or negative, does not matter. Those are ions. Whether the ion is created with the use of one atom or more than one atoms does not matter. They are all ions. So any particle that is created with the that is created such that there is an overall charge, that particle is an ion. Now, one discussion that we need to have, which is very important at this point in time, is the fact that ions and atoms or molecules are not the same things. They are totally different from each other. Sorry. Let me give you an example of what I mean when I say this. Earlier on we said when we write the letter O, uppercase O, that's an atom of oxygen. Note that there is no charge. That's an atom. But when we write O2, this is a molecule. Of course, in this case, it's a homoatomic molecule of the element oxygen. Please note, there is no charge. These atoms and molecules are neutral. They should have no charge. But as soon as you write O with a charge on top as a superscript on the right hand side of the symbol, this is an ion of oxygen that has a charge of 2 minus. Now when oxygen atom makes the ion O2 minus, this is a chemical process. Please take a moment and recollect the definition of a chemical process from a previous session. Whenever a chemical process happens, whatever you started out with gets used up and in its place something new gets created. In other words, O2 minus is not the same thing as O. They're totally different entities. They have very different properties. Similarly, Na sodium atom is not the same as Na plus, which is the sodium ion. They have very different properties. One very quick illustration that I would like to give at this point in time is sodium atom reacts explosively with water. Sodium ion, on the other hand, is something that we consume on an everyday basis. In almost everything there is salt. Is there sodium in salt? No, the answer is no. There is no sodium in salt, even though the container says so. Now that's a common vocabulary that the container has. We as scientists need to be a little bit more specific. What salt has is sodium ion, which is not the same thing as a sodium atom. When we consume salt, we are consuming sodium ions and we do not explode, even though we are mostly water. Sodium atom we can't consume. It is not possible. So please understand and please always remember that that ions and atoms and molecules are not the same thing. Whenever an atom or a molecule makes an ion, it is creating something new that did not exist before. Now, ions can be classified based on two criteria. The first one is the type of charge, whether the charge on that ion is a positive or a negative. Ions that have positive charge are called cations, whereas ions that have negative charge are called anions. Ions can also be classified based upon the number of atoms in one ion. So ions can either be monoatomic if one atom is needed to make one ion, or they can be polyatomic if more than one atom is needed to make one ion. So if you look very closely, this is a monoatomic ion because only one sodium atom was needed to make one sodium ion. So is this a monoatomic cation because one molybdenum atom made one of those ions. This is a monoatomic anion because one chlorine atom is needed to make one chlorine ion. But there are several ions, many ions out there that are polyatomic. In other words, one ion, one unit, actually in this case in NH4 plus needs 5 total atoms. One nitrogen and 4 hydrogen atoms together share one single positive charge in that one ion. Similarly, if you look at this one ion, it's one piece, one unit, which has a total of 4 atoms inside of it, and an overall charge, a total charge for that entire piece is 2 minus. So ions can either be cations or anions based on the type of charge, positive or negative, or ions can be monoatomic or polyatomic based on the number of atoms needed to make each of those ions.